Imagine an animal only slightly larger than the palm of your hand. Its body is covered in black and bright yellow stripes, as though nature tried to combine a hedgehog, a shrew, and a giant wasp. Instead of ordinary fur, dozens of sharp spines grow along its back. It has almost no visible tail. Its snout is long and narrow, and a crown of yellow quills rises above its head. When danger appears, this animal does not try to look harmless. It lowers its head, points its spines forward, and may charge directly at the threat. Its goal is to drive the sharp quills into the attacker's face. But even this is not its strangest ability. A group of specialized spines on its back can vibrate and rub against one another. This movement produces high-frequency sounds that humans can barely hear. In other words, this animal can communicate using its back. It is called the lowland streaked tenrec, and it is one of the most unusual mammals on Earth. It produces sound through a technique called stridulation. This method is far more commonly associated with insects, such as crickets. Why would a mammal need a musical instrument built into its body? Why does it look like a living warning sign? And how did such a small creature become one of the strangest animals on the planet? To answer these questions, we must travel to a place where evolution seems to have ignored the usual rules. The island of Madagascar. Madagascar lies off the eastern coast of Africa. For millions of years, the island remained isolated from other major land masses. The animals living there evolved largely independently from the rest of the world. This isolation produced lemurs, phosses, unusual chameleons, and countless creatures found nowhere else on Earth. Scientists believe the distant ancestors of Madagascar's tenrecs originally came from Africa. A small group may have reached the island by accident. They may have been carried across the ocean on a natural raft made of branches, roots, and vegetation. A flood or a powerful storm could have swept this floating mass into the sea. Such a journey sounds impossible. However, these animals would not have needed to cross the ocean in a single day. If the currents moved in the right direction and the floating vegetation provided enough food and fresh water, at least a few individuals may have survived. Once they reached Madagascar, the ancestors of modern tenrecs entered a world with relatively little competition from other mammals. There were forests, wetlands, rivers, mountains, and many empty ecological roles waiting to be filled. Some of their descendants became burrowers and began to resemble moles. Others adapted to life near water. Some evolved bodies that looked similar to shrews. Several species developed spines, making them look remarkably like hedgehogs. Today, scientists recognize around 36 species of tenrec. They can look completely different from one another, even though they belong to the same evolutionary family. But the streaked tenrecs are unusual, even by tenrec standards. The lowland streaked tenrec lives mainly in the humid tropical forests of eastern Madagascar. It moves through fallen leaves, thick vegetation, and damp soil, where its favorite food is hidden. At first glance, it is easy to mistake this animal for a strange species of hedgehog. But it is not a hedgehog at all. Tenrecs and hedgehogs look similar for the same reason that dolphins resemble fish. They adapted to similar lifestyles and face similar environmental challenges. Sharp spines are an effective defense against predators. Because of this, completely different groups of animals independently evolved a similar solution. This process is known as convergent evolution. When scientists examine the mammalian family tree, the tenrec's true relatives become even more surprising. Tenrecs belong to an ancient group of mammals with African origins. In evolutionary terms, they are more closely related to elephants than they are to true hedgehogs. This animal is not a miniature hedgehog. It is an extremely distant relative of the elephant that weighs between 125 and 280 grams. Its body is usually about 14 centimeters long. It is small enough to fit comfortably across 2 human hands. However, its combination of thick fur and sharp quills makes it appear larger than it really is. A bright yellow stripe runs across the top of its head, while several more stripes extend along its body. From a distance, the pattern resembles the warning colors of a wasp or a bumblebee. In nature, a combination of black and yellow often sends a clear message. Stay away. Wasps, bees, poisonous frogs, and many other well-defended animals use bright colors to warn potential attackers. A predator that has already experienced a painful encounter may remember those colors and avoid similarly marked animals in the future. The streaked tenrec may use it. However, scientists are not completely certain. On the forest floor, among patches of sunlight, dead leaves, and yellowing plants, the same pattern may also function as camouflage. When the tenrec remains still, its stripes can break up the outline of its body. This makes it more difficult for a predator to understand exactly what it is seeing. The result is an extraordinary combination. From a distance, the tenrec may disappear into the forest floor. But once it has been noticed, those same bright stripes seem to ask the predator a simple question. Are you sure you want to bite me? The most extraordinary part of the lowland streaked tenrec's body is located near the rear of its back. Among its ordinary defensive spines is a small group of highly specialized quills. These quills are different from the others. Together, they form a genuine sound-producing organ. Beneath them are specialized muscles in the skin. When these muscles contract rapidly, the quills vibrate and rub against one another. This produces a series of short, high-frequency signals. This method of producing sound is called stridulation. Crickets use stridulation when they rub
Found only
parts
in
of their
Madagascar,
wings together.
the lowland streaked
Other
tenrec
insects
forages on the
create
damp
similar
forest
sounds
floor,
by
using
moving
its sensitive
specialized
snout to
parts
find
of their
insects.
bodies. In the streaked tenrec, the instrument is made of spines. Scientific studies have described a group of roughly 15 or 16 specialized quills in adult animals. Underneath them is a small area of thickened muscle. This muscle works almost like a tiny motor, moving the quills quickly enough to create sound. Imagine a mother tenrec leading her young through dense grass and fallen leaves. The babies are much smaller than the adult, and they can easily lose sight of her. Researchers believe that the mother produces high-frequency
The
signals.
lowland streaked tenrec meticulously covers the entrance to its burrow, a vital defense against predators in this dense forest.
It is as though an invisible thread of sound connects the family together. Humans cannot easily hear this communication without specialized recording equipment. Scientists need sensitive microphones capable of detecting high frequencies. A person could be standing near an entire family of tenrecs without realizing that the animals are actively communicating. These sounds may do more than simply keep the group together. Some researchers believe the signals may also serve as warnings. One animal may notice a predator, raise its quills, and produce a signal that tells the others to hide or prepare to defend themselves. However, the tenrec's language has not yet been fully understood. We do not know whether a mother's signal differs from the sound made by a young tenrec, We do not know whether the signals can communicate the direction of travel, the location of food, or the presence of a particular predator. That mystery is one reason the streaked tenrec remains so fascinating to scientists. Its body can send messages that exist beyond the limits of normal human hearing. But its quills are not its only method of communication. Streaked tenrecs can hiss, squeak, make clicking sounds with their tongues, touch one another with their noses, and leave scent markings. Some researchers have suggested that tongue clicking may help tenrecs understand their surroundings. It is possible that they use a very simple form of echolocation. However, there is not yet enough evidence to prove that they possess a fully developed echolocation system. Think about this animal again. It sees the world with its eyes. It explores the ground with a sensitive nose. It gathers information from scents. It touches family members with its snout. And it sends hidden messages by vibrating the spines on its back. All of this happens inside a body only about 14 centimeters long.
The lowland streaked tenrec meticulously cleans its distinctive snout and quills, a vital behavior for this rainforest dweller. Here in the wet leaf litter, the tenrec senses movement. It immediately braces, using its sharp quills to deter the passing Madagascar ground snake.
But finding one beneath layers of wet leaves and soil is not a simple task. The tenrec lowers its long snout toward the ground and carefully investigates the surface. Its strong sense of smell helps it detect small animals hidden beneath the soil. When it senses prey, it uses its front paws to move leaves and loosen the earth. Its elongated toes and powerful front legs are well adapted for digging. Sometimes the tenrec begins stamping its front feet against the ground. Why would it do that? Scientists believe the vibrations may cause earthworms to move. The worms might mistake these vibrations for falling rain or for the approach of another underground animal. The moment a worm reveals its location, the tenrec quickly pulls it from the soil. From a human perspective, this hunting technique can look almost comical. A tiny black and yellow animal angrily stamps on the ground, as though demanding that its dinner come out immediately.